In this video, I'll be showing a new method I discovered of phasing through walls with a boat, which allows you to glitch through 2 block thick walls. I'll demonstrate this method now. This method is based on the mechanic that when you row a boat towards a wall and exit the boat right before you hit the wall, as you can see, the boat goes inside the wall, but this boat isn't actually in the wall. If I add another boat here and align it against the wall, we can compare these 2 boat z coordinates. Negative 56.3125 and negative 56.3125. And if we look at my z coordinate here, we can see that the z coordinate or the z axis is this direction. And so this boat has the same z coordinate as this boat over here, which means that it is actually aligned or up against the wall, just like this boat here. So it's not actually inside the wall. So client side, we see the boat as inside the wall, but server side, it's actually just against the wall. And if you wait a while, you can see that it syncs up the client side with the server side, and it goes back to the server side position. Another interesting thing about this boat that shows that it's in a client side position that we see is that if we place a block here, we're able to place it even though it's inside the hitbox that we see. But since the client doesn't think we can place it, it doesn't show the hand animation and it doesn't play the sound of placing the block. And when you get inside this boat, it snaps back to the server position. So in order to have this boat actually be inside the wall, we need to make the client think the boat is, or the server think the boat is where the client thinks it is. And in order to do this, you need a boat that is less than half a pixel inside the wall. So about this line here, so less than this, or about 1/32 of a block. And I'll try to do this here. Is that it? I think that's a bit over. Yeah, it's a bit over. And this is pretty difficult to do, so it might take a bit. That's also over. And that is too. Oh, there we go, we got it. I'll try to do it again. That's over. That's also over. I think that's good. Yeah, that looks like less than half a pixel. So this boat acts similarly to one that would be further inside the wall. It still does the placing thing here, but when you get inside this boat, it doesn't snap back to the server position. I'm not sure exactly why this happens when it's only a very small amount inside the block. A hunch I have is it may be because blocks, when you're inside of a block just barely, when you're on the very edge of a block, it doesn't push entities out of it, but that's just a hunch. So once you have the boat inside the wall, push it forward, and then you can row it inside the wall. And now, if we go in spectator, you can see that it's up against the halfway point in the wall. Now onto the second layer. I'd recommend using F5 when you're inside the boat, inside the wall, because it allows you to see when the boat is aligned against the wall, which helps a lot. But other than the site limitations, the second wall is actually easier than the first, and I'll demonstrate why over here. So let me get a boat inside the first block. There we go. And so now that we have it inside the first block, we can put it inside the second block. And that didn't, okay. It'll be easier to demonstrate if I can get it further inside the second block. I'll try to get it further inside the second block to demonstrate why the second block is easier. There we go. So this boat is past the half a pixel limit. But when we get in the boat, it doesn't snap back to the server position. And that's because the boat is already inside the block. And you also don't need to push the boat before you go forward. Which is why, other than the site limitations, the second layer is actually easier than the first. So if we do that over here, you can see we phase through the second layer. The problem with this method of going through walls with the boat is that it's very inconsistent and difficult to do. So how far the boat goes into the wall is determined by two things. The boat's momentum and when you exit the boat. So it's very difficult to get the boat the correct distance inside the block because the boat moves very fast compared to the time you have to exit it. And you can make the window of time larger, the window of time that you should exit the boat larger, by making the boat move slower towards the wall. And one way you can do this is by changing the angle of the boat against the wall. So if we change the angle, and we make it go, if we just change the angle, this angle change would make the boat move slower in this direction, since more of the speed is going to the left here. And this makes it significantly easier, as you can see we already got it, to get inside of the wall. We did it again. Another way of moving slower towards the wall is instead of rowing straight forward, you turn. Since turning moves you a very small amount forwards, you can use this to pretty consistently get inside of the wall a very small amount. There is a very weird mechanic with boats where if you have a boat facing a specific direction with a specific rotation, or just with any rotation, when you enter it and you exit it with a different rotation, some of the time it will change back to its original rotation, as you can see. And it does this once you exit the boat. So you can use this as a way to get very slightly inside the block. And this is pretty consistent. Finally, there is a way to make rowing straight forward much more consistent. Since rowing straight forward always goes either behind or less than half a pixel or more than half a pixel, all we need to do to make going more than half a pixel work for getting the boat inside the block is to stop it or enter the boat before it passes the half a pixel limit. And so I can demonstrate that here. You can just spam right click, as you can see. It's pretty consistent of getting the boat, or to get the boat inside the block. And it works pretty well, and this is the method I use, since it's pretty quick to set up and it's very consistent. And that's it. Thanks for watching, and bye.